Hello everyone, welcome to this session on Learn Docker in 60 minutes. Today in this session, I'll be taking you some of the most important concepts in Docker and we'll try to cover it in the next 60 minutes. So let's get started. So guys, this is the agenda for this session. This is what we are going to cover today. First, I'm going to explain you the difference between virtualization and containerization. After that, we'll be covering what is Docker, then move on to discuss the components of Docker, then talking about how you can go ahead and install Docker on a machine, then talk about what are the different kind of commands that you can use in Docker to do simple tasks, and then talking about how to create a Docker Hub account. And finally, I'll be showing you guys how you can go ahead and create a Docker file. So guys, this is the agenda for this session. I hope it's clear to you. Now let's move on and start off with the first topic, which is virtualization versus containers. So guys, virtualization is basically a process in which you launch multiple operating systems on top of an existing operating system, right? And you do that using a software called hypervisor, right? Similarly, if you see containerization, what happens is on top of an operating system, you basically install a software called container engine. So up till here, everything is same. You have hypervisor over here, and then you have container engine over here. That is the only difference. The host operating system is going to be the same. The hardware is going to be the same. The only difference is the software that you install, that is the hypervisor and container engine. Now, the way these softwares work is also very different. So in virtualization, what happens is the operating system that you install on top of the hypervisor software installs everything which is there in an operating system. For example, when you install a Windows operating system, the BIOS is installed, then all the drivers are installed, the GUI is also installed, everything is installed, right? But when you talk about containers, which basically are installed on top of container engine, not everything about the operating system is installed. The GUI is not installed. Only the bare minimum drivers or libraries are installed. The BIOS or kernel is also not installed, right? So the BIOS or kernel is basically used of the underlying operating system, right? That is the main reason containers are very small in size. So when you talk about a virtual machine, its size can go up to 4 or 5 GB in case of Linux, and up till 20 to 25 GB in case of Windows when no other software is installed. But when you talk about containers, its size can be as low as 30 MB, right, in size when no other software is installed and just the operating system is included inside the container. Right now, I would like to stress on the fact when you're using containers, it's not the whole operating system. It just has the bare minimum libraries which makes the operating system work, and otherwise the underlying kernel or the underlying BIOS of the operating system on which Docker has been installed is basically used. Now, this was the main difference between virtualization and containers, and because of this feature of containers, that they are very less in size, right? That the size is very small. They are used, dominantly across various IT companies as a unit of a microservice. Okay, moving forward, let's talk about Docker. So Docker basically implements the process or implements the idea about behind containerization. So guys, Docker is basically a software which was first released in 2013 by its parent company, which is Docker, and it basically follows the process of containerization, which basically means having containers which have the bare minimum libraries inside it and making use of the kernel or BIOS in the underlying operating system for the normal functioning of the container, right? That is what Docker is. So if I were to give you an example, let's say you want an Ubuntu Docker, right? The size is going to be hardly around 100 and 150 MB, right? So if you have a Windows machine, you just download the Ubuntu container, and now you can run all the Ubuntu commands in this Ubuntu container, and it will work as if you're working on an Ubuntu operating system. Similarly, let's say you want to work on CentOS, so just download the CentOS container, and that's about it, right? It will be arrayed in the size of around hundreds of MBs. You download it, you start working inside it, and it will work exactly how a CentOS machine basically works, right? So this is how this is what which is possible when you're using the Docker software. Moving forward, now let's understand the Docker container lifecycle. So you have the Docker engine, which basically you install on your machine. And what you do is on the Docker engine, you can run multiple containers. Now, all the containers that you run, first you have to download their image. For example, like I said, if you want to work with the Ubuntu Docker container, you will first have to download the image of the Ubuntu Docker container, and then you run it on that machine, and then only it runs it, as an entity which is called a container. For example, you can just imagine it like this. If you want to install or run Windows on your machines, what you'll have to do is you'll have to download the setup file for the Windows operating system. Only then it will work. Similarly, in Docker also, first you have to download the images, and then you run those images as a container for the Docker containers, right? Now, so like I said, you install the Docker engine first on your machine, then you download Docker images, and in these Docker images, then what you do is you can do different kind of operations using these Docker images. You can run these Docker images as containers, you can stop these containers, or even you can delete these containers. Okay, so once you have run the container, you have installed the software that you want to run in it, you have basically put the code which has to run in that container. Once you feel that container is ready and you want to share it with the world, what you can do is you can upload it to a central repository called Docker Hub, which can be accessed by everyone if they have the required permissions to do it, right? So it's similar to what you do in GitHub basically is a central repository where you can upload your code. Similarly, when you download a Docker image, you customize it according to your needs, then you can upload that custom image on a Docker Hub central repository, and then anyone else, let's say a colleague, if he wants to use that image of yours, he can download it from there and then start working on his machine. So that's what Docker Hub is. So there are two operations that you can do on Docker Hub. One is push, which means uploading, and one is pull, which means downloading. So in the beginning, when you download an Docker image, let's say of an Ubuntu operating system or of a CentOS operating system, the image gets downloaded from Docker Hub itself. Okay, so guys, this is the life cycle of Docker. This is exactly also something that we are also going to mimic today, and we are going to understand each and every part of this life cycle and see how it basically is going to work. Okay, now let's go ahead and understand the different components that we just discussed over here in terms of individual entities. So first thing, let's understand what is Docker Hub. So Docker, I already told you, it's a central repository where you can upload all your your custom Docker images and all the existing Docker images as well, which you basically use to start working with containers, is also present on Docker Hub. Docker Engine is basically the software which you install on your machine, right? That is basically the software which is going to run your containers. Docker images is basically kind of like the setup file which you download in order to make your container to work. Then you have containers, which are basically the running entity, right? So when you when you download the Docker image, and now when you want to run it, the it basically runs it as a container. So that's what a container is. It's basically a software environment which runs once you give it the Docker image, using which it's going to create that environment. Okay, then you have something called as Docker volumes. So Docker volumes is something which is which can be attached to a Docker container, and it basically serves the purpose as the same as what you have in your hard disk. So for example, if you have a hard disk of your machine, you can install additional hard disks as well, and then you can create multiple partitions in it as well. So those are what what you refer to as Docker volumes when you want to add additional disks to your already existing container, right? And once you are done with the work, these disks can be removed and can be attached to other Docker containers as well if required. So those are what Docker volumes are. And finally, then you have something called as Docker files. So it's an advanced concept that we are going to cover today. And Docker files basically help you to create an environment, right, which you want. For example, it could be that let's say a developer is working on a code, and that developer does not know Docker, right? But that developer, when he has to give his work to someone, he wants it to first check if everything is running fine or not. So as a company or as a DevOps team, what you have decided is no machine will have the environment installed on it manually. Everyone has to test their code inside Docker containers. But the problem is that these developers, they do not know about Docker. So you can use something called as a Docker file, which basically is going to pick up the code, deploy it in the software environment of your choice automatically, but just by using a single command, right? And that is also something that we are going to discuss as we move along. And I think the use case for it will be more clear when you actually implement a hands-on on a Docker file. Okay, so guys, those are going to be the components of the Docker ecosystem that we are going to discuss today. Moving forward, now let's talk about how we can get started with Docker by installing it. Alright guys, so now let's go ahead and install Docker. So for installing Docker guys, you have two methods. One is for Docker installation on Windows. You can just do a simple Google search Docker for Windows and you will get to the guide over here, and you can just follow it to install Docker on Windows. And then you can install Docker on Linux as well, right? So what I'm going to show you is how to install Docker in an Ubuntu operating system. Alright, so the first thing that you do is just go ahead and update the machine. So sudo apt-get update, and this Ubuntu operating or this Ubuntu server I basically launched on AWS. You can also launch a virtual machine of Ubuntu on your system, and then you can try doing the same. Okay, so the machine is now getting updated, and once the machine is updated, what I'll do is I'll go ahead and install Docker. Alright, so so machine has been updated. Let's go ahead and install Docker by using the command sudo apt-get install docker.io. So with this, the Docker software will now be installed. Okay, so once this process is over, now let me switch back to my local machine. So once this process is over, Docker will be installed, and then you can simply do a docker ps, and then you can see that it will show you an output like this. So PS basically means list out all the containers which are there on your system. We'll be talking more about this in a little while. Also guys, when you install Docker for the first time, you will have to use sudo with Docker in order for it to work. So what you can do is you can just type in sudo su, and then with this, as you can see, I'm on my hash terminal which right now, which basically means root. And when you're on your root, you can just type a docker ps, and then your command will work. Otherwise, what you can also do is, like what I've done is I've configured Docker to work with my user as well. And the way you can do that is just do a simple Google search. Just type in use Docker without sudo, right? And then there's a Docker documentation as well for this. So you will have to run these commands: sudo add group add docker, sudo user mod. Just run these commands, and after that Docker will run without sudo as well on your system. So let me check if this is complete. So I think this will be complete in another 1 minute. So let it complete, and then I will show you how we can use Docker without sudo as well. So let's give it some time. So the download is now complete. Now Docker is basically getting installed. It should just take a couple of seconds now. And yes, Docker has now been installed. So now if I just use docker ps, you will see that I'll get an error like this. It says permission denied. And in order to use Docker, I'll have to use the command sudo docker ps, and only then it will give me the same output. Now how to avoid this? What you can do is just follow these commands. So first, let's try to add sudo. Okay, so it says group docker already exists. Great. Then just modify the user docker. Done. And now you can just type in this command to go ahead and activate the changes, and now it should be fine. So if I go ahead and type in docker ps, you can see without sudo the commands are now running fine, right? So this is how it has also been set up on my local. So if I run docker ps, you can see I'm getting the same output. So even on Windows, when you install Docker, so in that case, when you install it on Windows, you will not have to use sudo, right? If you just run docker ps, you will get the same output. Okay. So with this, guys, this is how you go ahead and install Docker. Now let's move ahead and talk about the common Docker commands using which you can explore Docker further. So let's go ahead. Alright guys, so let's go ahead and see the first command. So guys, first of all, let's understand how you can go ahead and see the version of the Docker that you're using. So let me open the terminal quickly. And the version you can see like this. So Docker -- version will give you the Docker version that is installed on your system. After that, let's talk about pulling an image from Docker up. So how can you do that? So let's say this is my Mac operating system. What I want to do is I want to go ahead and pull the Ubuntu image. So Docker pull Ubuntu. So with this, the Ubuntu container will now be downloaded to my system, right? So it will take some time, probably a minute or so, and then it will install or it will basically download the Docker image on my system, right? So as you can see, the Ubuntu image has now been downloaded, right? Now, if I want to go ahead and see where the images are on my system, I can just type in Docker images. And with this, I have these many images, but if you can see, Ubuntu images has just been downloaded on my system. It shows here 2 weeks ago because this is the time when the developers of Ubuntu probably would have done an update to this image, and this image was updated 2 weeks ago by those developers, but it has just been downloaded on my system. And for seeing all the images which are there on your system, just type in Docker images, and as you can see, these are all the images that are there on my system right now. Moving further, if you want to go ahead and run an image, then the command is basically this: docker run. So let's go ahead and use that. So I'll just type in docker run. Then one thing that you have to take a note of is that whenever you're running the Docker, any container that you're running, if you want to access that container and if you want it to keep running, then in that case, what you'll have to do is you'll have to type in this command: docker run -it, which means give me an interactive terminal, put all the output to an interactive terminal, and also run it as a daemon, and also keep it running even if I'm not using that container, and then the image of the container, which is Ubuntu. Okay, so docker run -it-d Ubuntu, hit enter. So this is the interactive terminal. You've got the output, right? And now this container is running as a daemon in the behind scene. So if I do a docker ps, you can see that this container is running now. Although I'm not touching this container, I'm not running inside this anything inside this container, but still it's running as a daemon in the backend. So that would be the next command, docker ps, which we have already discussed, which is basically to see how many containers are running in your system. So currently only one container is running in my system with the image Ubuntu, and this is the container ID of the container. This is always unique. Okay, now if I want to see all the containers in my system which are running or not running, but they were running at some time, if I want to see, or inactive containers if I also want to see on my system, then the command is docker ps -a, right? And with this you can see that there are two containers which are running on my system. This container is created 58 seconds ago and the status is up. This container, it was created 3 months ago by me and the status is exited. That means the container is no longer running. And this is a custom image of container that I was running. As you can see, the number is over here. There's no name. That means this image is not tagged. And this was running 3 months ago. So if you want to see all the containers that are there on your system but are not running, you can just type in the command docker ps -a, and that will give you all the containers which are running. So it will show you all the stopped containers as well. Now, if you want to go inside the container, the command is docker exec. So you can only go inside running container. So the running container is this Ubuntu container that I have right now. So if I want to go inside this, the command is docker exec. Now again, all the way I want to interact with this terminal is using the terminal. So I'll have to type in -it, then the container ID, and then which terminal do I want to interact with it on? I wanted to interact on the bash terminal. Okay, so in Linux, the bash is the default terminal that you interact with. And now as you can see, I'm inside the container. I'm basically using the root account of the container, and this is the container ID, right? So whatever I'm going to execute here is going to be executed inside the container. Okay, then you can also stop the container. So in case I want to go ahead now and I don't want to use this container anymore, so what I can do is I can just exit from this container. I can type in docker stop the container ID, and it will return you the container ID again, saying that this container has been stopped. And if I do a docker ps now, you can see there's no container running. And if I try to do an exec into this container as well, it will say error from daemon container, this is not running. So if the container is not running, you cannot go inside the container as well, like I told you. Right now, let's say some container is not stopping, right? Some probably some software is running that inside that container, and it's not stopping for some reason. It's similar to you doing a hard reset of your system when the system hangs, right? So similarly, if your container hangs, just by running the docker stop command, the container will not shut down gracefully. So if the container is not shutting down gracefully, what you can do is, let me run this container again. So docker start. So you can again start this container using the docker start command, and as you can see, the container is now running. If I do a docker ps, so if I want to kill this container, I can do a command called docker kill, put in the container ID, hit enter, and now if I do a docker ps, you can see the container is no longer running because this container has been hard reset, or it has been hard stopped. It has not been shut down gracefully. Okay, so that's what the kill command does. Then what you can also do is you can remove a container. So in case, let's say I want to go ahead, and if I go ahead and see docker ps-a, I have two containers which are there in my system, although they are not running. So if I want to go ahead and delete these containers, I don't need them anymore. So what I can do is I can type in docker rm and then the container ID, and it gives me an output back of the container ID that I entered, which means it has been deleted. Let's delete both these containers. So docker rm, again a container ID. Okay, this has already been deleted. So docker rm and then container. And now if I do a docker ps-a, you can see none of the containers now exist on this system, which basically means all the containers have been deleted. But mind you guys, the docker images are still there. So how do you go ahead and delete docker images? Is done using the command docker rmi. Okay, so how can I delete images on a system? So let's say I have a lot of images which are here: MySQL, Confluent, Nginx, HTTPD. So let me go ahead and remove some images. So I'll just type in docker rmi. Let's say I want to delete all the previous images, so I can just type in all the image IDs by giving a space. And with this, I can delete multiple images from my system. Okay, so as you can see, the images are getting deleted. And I can also do something very neat. What I can do is I can type in a command through which I can delete all the images on my system. So I can just type in docker rmi, and then I have to type in dollar and then docker images. And if I pass this command, all the containers will get deleted from this system. But I'm not doing that as of now. But if you want to delete all these containers from your system without specifying all the IDs, this command will help you do it. Okay, so we have now understood docker rmi. Now, these were some of the commands, guys, that you would need to basically go ahead and get up and running with a docker container. Now let me show you some cool stuff before we move on to docker hub account. Let me go ahead and show you some cool stuff that you can do with your docker container. So let me run a docker ubuntu container again, and the container is now running. Let's go inside this container. So again, I'm using the commands that I just discussed with you. I'm inside the container, and now what I want to do is, let's say I want to go ahead and install some software inside it. So let's update this container first. So I'll just do an apt get update. So this container is getting updated now. And mind you guys, this command will not work on my local system. So if I run the same apt get update command on my local system, that is without the container, it says apt get command not found. Why? Because this is me inside the container and this is me outside the container. So if I'm outside the container, these commands will not work. These will work only inside the container, right? Similarly, whatever you do inside the container is going to be separate from what is there on your host operating system. For example, right now I'm going to install a software in this container. Okay, and in order to do that, the command would be apt get install Apache 2. So I'm going to install the Apache 2 software in this container, and then we are going to see if we can access this software from the outside. Okay, so I'll just hit enter. So this container is now installing the Apache 2 software. Okay. There's one thing that we forgot, guys. So let me quit this container. So just give me one moment. Okay, let me exit this container. So what I have to do is I will have to map a port of this container onto my local system. So Apache 2 basically works on port 80. So let's say if I type in localhost over here, right now there's nothing there on the local host, right? So this local host basically works on port 80 when I just type in localhost on my browser. So what I want is whatever is there on port 80 of the Docker container should be there on the port 80 of my host system. So in order to do that, I'll have to type in something like this: docker run -it-d Ubuntu. This is the command that you have learned. Now here I will add a flag called -p, in which I'll specify port 80 of my host system should connect to port 80 of my container. Hit enter. Now the 80 port of my container is connected to the 80 port of my host. And now what I can do is again go inside this container and now update the machine like we were doing before. So in the previous step or in the previous container, we did not connect the port 80, and hence even if we install the software, we would have not been able to see it on the browser. But now by doing apt get install Apache 2, you will be able to see that software that I'm installing in this container on the browser. So Apache 2 is basically a web host software where you can host websites. So if I host a website inside this container, you guys will be able to see it on my browser. So that is exactly what I'm trying to show you guys over here. So here I'll have to choose my geographic area. So I am in Asia, and please select the city or region corresponding to your time zone. I think I'll have to choose Kolkata, so it's 44, and now it's getting installed. Okay, so the software has been installed. Let's check the status of the software. So service Apache 2 status. It says Apache 2 is not running. So let's run this. So service Apache 2 start, and now it should be running. So it says Apache 2 is running. So now if you go to a browser and refresh, you can see the Apache 2 software is now visible. Why? Because this container is running that software inside it. Right? And if I run the same command over here, guys, you will see that there is no service called Apache 2 on my system. Right? So let's say so even the syntax is not working. See Apache 2 status. You can see it's not working. It's inside this container that the Apache 2 software is working. Okay. Now what I can also do is I can just do an ls, and let's say I go to the part where this index.html is present. Okay. Now let's say I add a page over here. So let's say I add echo hello world to a 1.html file. So I have a 1.html file over here which has the text hello world, and this is inside the container, guys. So what I can do is I can come back over here and I can just type in localhost 1.html, and you can see the hello world text that I wrote in 1.html over here in the browser. And how is this possible? Because this is being hosted from inside the container. Right now, how can I prove it to you that this is inside the container? What I can do is, let me type in docker ps, and this is the container which has the port 80 mapped to port 80 of the machine. I can go ahead and stop it. So docker stop the container ID, and now if I do a refresh over here, you can see that the page is not loading, and it will give you a connection timeout now. Why? Because the container has now been stopped. Right? So if I hit refresh, you can see refuse to connect. Why? Because the container itself is not available now. However, if I go ahead and start it again, and if you go inside this container now again, so now this container already has the software. All I have to do is service apache 2 start, and now the service has been started. And if I refresh, again you can see the Apache 2 software, and even the 1.html will still be present. Okay, so guys, this is how you can go ahead and launch your first container in Docker on your local system. Now whatever I've done over here can similarly be applied on the AWS machine as well. So this is my AWS machine, right? So I can do the same steps over here to replicate what I've just done. So I can do a sudo apt. So let's first pull an Ubuntu container. So this is my AWS, guys, right? And now the container has been pulled. Let's run this container now. Sudo docker run -it -p 80:80 -d and then Ubuntu. And now if I go ahead and go inside this container, I can go ahead and update this container. And now I can install Apache 2 inside it. So again, it'll ask me the region from where I'm installing it. So I'm installing it from Asia and then from Kolkata. And now let's check the status. It's not running, so let's run it. So it has been started, and now for accessing it on the browser, all I have to do is get the IP address of this server wherever it is running. So it's running inside my AWS. In my EC2, it's in the Mumbai region. So I can just get the IP address of this server, which is this, copy it, paste it, and you can see the Apache 2 page is visible over here. And if I go ahead and if I stop this container, and if I refresh, you can see it says refuse to connect. So what I'm going to do is let me start this container, and you guys can try going to this IP address. and even you guys would be able to use this service. Okay, so the IP address is 15.207.223.96, and you guys can confirm whether you are able to see this in the chat box. And if yes, that means you're seeing a container or you're seeing a website which is being hosted inside a Docker container, right? So guys, this is a hands-on which is pretty cool according to me. For your first day, if you don't know Docker anything till now, this should be a milestone for you when you're learning Docker. Moving further, let's come back to our slides. Let's now talk about how you can create a Docker Hub account. So all you have to do is go to hub.docker.com, and here you can sign up. So just click on sign up. Put a Docker ID which has to be unique. Put an email address, put a password, click on I'm not a robot, click on sign up, and you're all set. And once you have a Docker Hub ID, I can just show you how it will look like. Let me log in. Yes. So these are some Docker containers that I've uploaded over here, right? So once you have a Docker Hub, this is how it will going to look like. And now what we can do is probably I'll just come back to my local, and let's say this container which I created, which has Apache inside it, I can go ahead and save this container and then upload it to Docker Hub. How can I do that? Let's go ahead and check. So I've just showed you how you can set up your Docker Hub account. And now what you can do is you can commit changes, whatever changes you have done inside a container, you can go ahead and save it, right? And how you can save it, we basically went ahead and took an Ubuntu container. We installed Apache inside it. And now what we're going to do is we're going to commit these changes or save these changes to a container and make it as an image. Okay, and then we're going to upload this image onto Docker Hub. So first we did Docker pull, we did Docker run, we did Docker exec, we installed Apache 2. Now we're going to go ahead and commit the container. So how you can commit the container? Let's say you'll type in Docker commit. Let's say this is the container that you want to save. So I'll be putting in the Docker container ID for it, space. Then if this container has to go into your Docker Hub, you'll have to type in the Docker Hub ID. In my case, it's this / whatever container name where you want to give to it. In this case, let's say it's a demo, and today is 8th September, so 0809. Hit enter. So this container will now be saved, and if I do a Docker images, you can see that this container has been saved. And now what I can do is I can simply do a Docker push and then just type in this name. Now it will ask me the Docker Hub ID. So it says the requested access to the resource is denied. Why? Because I'm not logged into Docker Hub from my terminal. So I can just type in Docker login. It'll ask me my username, which is this, and then my password, which is this. It's gonna say login successful in case my username and password are correct. As you can see, it says login succeeded. And now I can pass in the same command, and now it will start pushing onto my Docker Hub. So this will take around a minute or so for the image to be pushed. And once this image is pushed onto Docker Hub, anyone in the world can access this image by just typing in Docker pull and the name of the image, which in this case is hshar/demo 0809. So once you have installed Docker on your machine, guys, you can go ahead and pull this image which I've just created by typing in docker pull hshar/demo0809. Right, it is free for all. Why? Because the Docker Hub account that I have is a free account, so it's an open account. So what happens is, like in GitHub, if you upload the code, right, and if you make it a public repository, everybody can download or see your code. Similarly, Docker Hub, the image that I'm uploading is public in nature, so everybody in the world would be able to use this image or download this image for their own use. Okay, so let it complete, and then I will show you how you can how I can pull this container from on my AWS machine. Alright guys, so now that the image has been uploaded, what I can do is I can simply go to my AWS instance, and I can see that if I type in docker pull hshar/docker or demo 0809, it will be able to download this image on this system. Right, and once this image is downloaded, you can go ahead and use it as well. So even you guys can go ahead and download this image and use it for your own purpose. All right, so now let me just go ahead, come back to my slides. So I just showed you how you can save your container, and I also showed you guys how you can push to your Docker Hub account by first logging in, then typing in the docker push command, and then okay, yeah, so I forgot to show it on your to you on the UI, basically where it is uploaded. So if I refresh my Docker Hub account, you can see that hshar/demo0809 has now been uploaded, and it was uploaded 2 minutes ago, right? So guys, this is how you can go ahead and push a custom image on Docker Hub. Coming back, you can also create a private registry for Docker, and the way you do that is by creating your own, your own place where you can basically store your Docker image, and then the systems which are connected to you on the network, the same network, and then we go ahead and download from that same place, right? And the way you do it is there is a container available for creating a private registry in Docker, and let me just show you. If you type in Docker private registry, so this is a container which you can go ahead and launch on your system, and in that case, that instead of basically pushing your image to Docker Hub, it will then start pushing the image to this local registry. But let's keep this for some other session. It's very simple. You can just go ahead and follow this documentation in order to get this done. Let's move on and now talk about what is a Docker file. So guys, a Docker file is basically a textual document that you can write, and once you execute that document, a Docker container is created with respect to whatever you specify in it, right? So these are some prefixes or some commands that you can use in a Docker file in order to get it working. For example, whenever let's say I want to go ahead and create an Apache 2 container. So the way I can do it is, first I will download an Ubuntu container, then I will run that container. First I will download an Ubuntu image, then I will run it as a container, then I will install the required softwares inside it, right? And then I will go ahead and save it as an image. So similarly, what I can also do is I can go ahead and type in a Docker file from Ubuntu. From Ubuntu basically specifies which image you have to download. So from Ubuntu, then add basically command, what it does is it adds a file which is there on your local system into the Docker container. Okay, so it adds whatever is there in the current folder where the Docker file is present. It adds whatever is there inside this particular folder, which is /var/www/html, which is basically the folder where your index.html is present, right? And then what you can also do is you can go ahead and install Apache 2 by using the run command. So run command basically helps you to run commands inside the container, right? So if you want to go ahead and run install Apache 2, you'll have to type in apt-get update and apt-get -y install Apache 2. After that, what you can also do is you can run Apache's, Apache, what do you say, the Apache software. So we had to start the Apache software manually, as you would have seen when you run the container. But if you want to avoid that, you can specify a command like this, and then in that case, the Apache will start running automatically the moment you run the Docker file, right? Similarly, the same entry point command can also be used, and then you can also specify an environment variable inside your Docker container by passing a command like this. Okay, so let's go ahead and run or create a Docker file like this, and let's go ahead and see how this basically works. So what you can do is, let me come back to my terminal, let me come back to my local terminal. So what I can do is I can create a folder. Let's create a folder called Docker. Let's go inside this folder, and inside this folder what I can do is I can go ahead and create a Docker file. Just type in from. So from, let's say, hshar/demo. Let's use the image that I already have. And in this image, what I want to do is I want to add whatever is there in the current folder. I'll add in. So let's say I want to add 2.html, which I will add in this current folder, to this path in my container. And then what I want to do is I want to type in this command. Okay, so this is basically telling you that uh, run the Apache software in the foreground the moment the container starts. And let's say this is something that I want to do. So basically what this Docker file is going to do is whatever is there in your current folder, it will add it as a file inside the container, and then it will run Apache software inside that container, right? So let's save it, and let's create a 2.html, and let's say I create an HTML like this, where I put the body, where I put one h1, and inside this h1 what I can say is hello world from Intellipaat, right? I can close this h1, close the body, and then close the HTML. Save it. And now what I can do is I can just type in docker build build the Docker file which is there in this container in this folder. So dot and then -t, and then I can specify a name of the image which will be created from this Docker file. So let's say it's try demo. Hit enter, and now an image will be created if you type in Docker images, which is called try demo. And if I run this image now, run -it, let's say I run try demo, and I run it on the port 82, let's say, and I map it to port 80 of the container, and I run it as a daemon in the background. Hit enter, and now if you go to port 82 on the browser, you can see an Apache page is visible, and if I type in /2.html, it says hello world from Intellipaat, which was basically a file which I created on the local. So mind you guys, I did not touch the container. I created a Docker file, and that Docker file basically went ahead and created an image for me which automatically had the file inside it. And this is how you can give it to a developer as well who does not understand a thing about Docker, and all you tell him is that just take this Docker file and run this command, or sorry, run the docker build command first, and then run the docker run command, and then you will be able to see your code in the browser. That's all the thing that you tell him, and then he's able to access whatever code he has written inside the Docker container. So guys, this was it for the session today. I hope you guys have learned something new. And stay tuned. And now I have my colleague who's going to help you out and understand if you want to learn more about Docker and other DevOps tools which are out there, how you can do so. So stay tuned. Have a great day ahead and goodbye.